A massive building is completely engulfed in flames. Towering columns of fire rise high above the roof as one fire engine after another races to the scene. Most people assume that putting out the fire is simply a matter of spraying enough water onto the flames. But there's one surprising fact that very few people know. The water tank inside most fire engines only holds enough water to operate for a few minutes. Once that supply is exhausted, a vehicle worth hundreds of thousands of dollars becomes little more than an empty metal tank. That's why firefighters don't focus on the flames first. Their first priority is finding a reliable water source. It could be a fire hydrant, a nearby river, a lake, or even another fire truck. Every second matters, and every mistake can cost an entire building. What many people don't realize is that the most important part of a fire engine isn't its water tank at all. The real heart of the machine is hidden deep inside its body. Today, we'll explore how a modern fire truck actually works and discover the incredible engineering that helps save thousands of lives every day.
But this creates another engineering challenge. What happens if there are no city hydrants nearby? What if the only available water source is an old village pond, a river, or a deep well located away from the road? Firefighters lower thick suction hoses into the water and activate the pump. Surprisingly, nothing happens at first. The reason is simple. The truck's main pump is designed to move water, not air. Its impeller blades can push heavy liquid with tremendous force, but they cannot pull lightweight air into the system. If the pump is empty, it simply spins without accomplishing anything. On its own, the fire truck can't draw a single drop of water from a pond. To solve this problem, engineers added a second, much smaller device inside the truck, a priming pump. Before the main pump begins operating, this small pump removes all the air trapped inside the hoses and internal pipes. As the air is evacuated, a partial vacuum forms inside the system. Then, one of nature's most fascinating principles takes over. Atmospheric pressure pushes down on the surface of the pond, forcing water upward through the suction hose and into the empty pump. In other words, the water isn't actually being pulled upward, it is being pushed upward by the weight of the surrounding air. Once sensors detect that the hoses are completely filled with water, the priming pump automatically shuts off. Now, the real heart of the fire engine comes alive. The powerful centrifugal pump takes over, ready to deliver thousands of liters of water directly onto the fire. Many people picture a fire truck using a giant piston pump, similar to a bicycle pump that simply pushes water forward. That idea is completely wrong.
To keep a fire engine operating under extreme conditions, engineers had to completely rethink how the vehicle delivers power. They introduced a critical component known as the power takeoff, or PTO. This remarkable mechanism sits between the truck's transmission and drivetrain. With the flip of a switch inside the cab, the driver can redirect the engine's power away from the wheels and straight to the water pump. As soon as the PTO is engaged, the truck no longer uses its engine to move forward. Instead, every bit of horsepower is transferred through a heavy-duty drive shaft directly into the centrifugal pump. The engine roars at full power while the truck remains completely stationary. In that moment, the fire engine transforms into a massive mobile pumping station, capable of moving thousands of liters of water every minute. But transferring that much energy introduces another challenge. The water must travel through hoses strong enough to withstand enormous pressure without failing. Many people assume that all fire hoses are basically the same, just thick rubber tubes. In reality, firefighters use two completely different types of hoses, each designed for a specific purpose. The flexible hoses carried into burning buildings are called discharge hoses. Their job is to deliver water under extremely high pressure. Although they appear soft and lightweight, they're built from layers of high-strength synthetic fabric lined with a smooth rubber interior. When empty, they lie flat, like folded ribbons.
The next challenge is projecting it onto the fire from a safe distance. For massive industrial fires or large warehouse blazes, handheld hoses simply aren't enough. That's when firefighters rely on one of the most powerful tools mounted on the entire vehicle, the roof-mounted monitor, often called a water cannon. From the outside, it looks surprisingly simple, almost like an oversized garden sprinkler. But behind that simple appearance lies an extraordinary feat of engineering. The monitor can discharge dozens of liters of water every second, creating an immense reaction force. If engineers had miscalculated even slightly, the recoil alone could tear the cannon from the roof, or in extreme cases, destabilize the entire truck. To control these enormous forces, the monitor's internal channels are carefully shaped to balance the flow of water before it exits the nozzle. The cannon itself is securely mounted to the truck's reinforced steel frame, allowing the recoil to be transferred safely through the chassis and into the ground. The operator can also instantly change the shape of the water stream. With a single movement of the control lever, a tight, concentrated jet capable of reaching incredible distances can be transformed into a wide mist of tiny droplets. This fine spray absorbs heat far more efficiently, rapidly cooling the surrounding air while creating a protective water curtain that shields firefighters from extreme temperatures and radiant heat. But sometimes even millions of droplets of water simply aren't enough. Certain fires cannot be extinguished with water alone. One of the most dangerous misconceptions is the belief that burning gasoline, oil, or fuel tanks can be put out by spraying water on them.
Supplying water to multiple firefighting teams at the same time creates a difficult engineering challenge. How do you maintain stable pressure throughout the entire system when every firefighter is using water differently? The answer lies inside the truck's water distribution manifold. Hidden within this control system are a series of intelligent pressure-regulating valves that constantly balance the flow throughout the entire network. Imagine a firefighter working inside a burning building. Suddenly, they close the nozzle to move into another room. At that exact moment, thousands of liters of pressurized water are still racing through the pipes. If there were nowhere for that water to go, an extremely dangerous phenomenon would occur. It's called water hammer. The sudden stop creates a powerful pressure wave capable of rupturing steel pipes, damaging expensive equipment, or violently jerking hoses from firefighters' hands. To prevent this from happening, the fire engine automatically detects the pressure spike. Within fractions of a second, relief valves redirect the excess water back into the system, safely circulating it until normal flow resumes. As a result, the other firefighters continue working without even noticing the interruption. But pressure spikes aren't the only invisible danger hidden inside the pump. There's another destructive force that operates silently. Many people believe that ordinary water could never damage a heavy-duty stainless steel pump. That assumption is completely wrong. Under the right conditions, water alone can destroy one of the strongest metal components inside the fire engine. The culprit is a phenomenon known as cavitation. It begins when the pressure inside the pump drops below a critical level. Although the water remains cold, tiny vapor bubbles suddenly begin forming inside the flowing liquid. As these microscopic bubbles travel into areas where the pressure rises again, they collapse with incredible violence. Each collapsing bubble creates a tiny shock.
It also explains something most people rarely think about. Have you ever wondered how these enormous trucks, carrying several tons of water, can race through narrow city streets at high speed without tipping over? Many assume that a fire engine is simply a giant tank balanced on wheels. In reality, every centimeter of the vehicle is carefully designed to achieve the lowest possible center of gravity. The heaviest components, including the water tank and centrifugal pump, are mounted as low as possible on the chassis. Storage compartments follow the same principle. Heavy rescue tools such as hydraulic cutters, spreaders, rescue saws, and pry bars are stored on the lowest shelves. Lighter equipment, including protective clothing, breathing masks, and medical supplies, is placed higher up. This carefully engineered weight distribution gives the truck exceptional stability, allowing drivers to maneuver confidently through traffic, take tight corners safely, and reach emergencies as quickly as possible. Eventually, the fire is extinguished. Smoke clears, the danger passes, and the mission appears to be over. But for the fire engine, the work has only just begun.
When the last flames are finally extinguished and the smoke begins to clear, Most people assume the fire engine's job is over. In reality, an equally important process is just beginning. The moment the truck returns to the fire station, firefighters immediately begin a strict maintenance routine. Every minute counts because the vehicle must be fully prepared for the next emergency at a moment's notice. Nothing is left to chance. The truck is never parked dirty after a fire. Any foam concentrate left inside the plumbing can dry and harden, damaging expensive valves and internal components. To prevent this, the entire pumping system is thoroughly flushed with clean water, removing every trace of chemical residue. The hoses receive just as much attention. After hours of carrying water under extreme pressure, every hose is carefully inspected for cuts, abrasions, worn couplings, or hidden damage. Wet fabric hoses are never simply rolled up and stored. Instead, they are hung inside tall drying towers, allowing moisture to evaporate completely. This prevents mold, mildew, and internal deterioration that could weaken the hose during its next deployment. Once dry, fresh hoses are neatly rolled, inspected once more, and carefully returned to their designated compartments. The water tank is immediately refilled to maximum capacity with fresh water. The foam tank is...
Even after all the engineering, all the electronics, and all the powerful machinery, the most important system on a fire engine is still the one that cannot be manufactured in a factory: human judgment. A fire truck may carry thousands of liters of water, generate enormous pressure, and operate with incredible precision. But every decision about where to position the vehicle, which hose to deploy, when to switch to foam, and when to retreat from a collapsing structure is made by trained firefighters. The machine provides the power. The crew provides the strategy. During a major fire, conditions can change in seconds. Wind may suddenly intensify the flames. A roof may weaken without warning. A fuel source may ignite unexpectedly. In those moments, the fire engine becomes more than a vehicle. It becomes a platform that supports an entire team of specialists working together under extreme pressure. Modern fire engines are designed with this reality in mind. Controls are positioned so operators can react quickly. Compartments are organized so equipment can be reached in darkness or heavy smoke. Emergency lighting, communication systems, and safety interlocks are all engineered to help firefighters make critical decisions as fast as possible. What makes a fire engine truly remarkable is not any single component. It is the way every system works together. The engine powers the pump. The pump feeds the manifold. The manifold balances the pressure. The hoses deliver the...
Because when a fire engine arrives, people are usually experiencing one of the worst moments of their lives. A family may be trapped inside a burning home. Workers may be trying to escape a factory. A highway accident may have ignited leaking fuel. In every case, firefighters depend on their truck to work perfectly the first time. And that is the real story hidden behind the flashing lights and the siren. What appears to be a simple red truck is actually a carefully engineered rescue system built to operate at the edge of mechanical possibility. It is a machine designed to fight heat, pressure, smoke, fuel, gravity, and time itself. Every call tests that design. Every fire proves why it exists. And every successful rescue is a reminder that behind the roar of the engine and the spray of water stands one of humanity's most important inventions: a fire engine built to protect lives when every second matters.